Black holes have been the holy grail of cosmology since the time Einstein conceptualized them in his theory of general relativity. Well, as it turned out, thanks to Dr. Stephen Hawking, we know that not only do they exist, but are so enigmatic and powerful that they bow to no rules of physics and challenge the theory of general relativity as well. Over the years, they have challenged the most brilliant minds of humanity and continue to do so with their mysterious existence. Even Stephen Hawking found himself wrong about them more than once. What makes them move? Are they ageless entities that will live beyond the time of the universe? And what exactly would cause your death if you ever fell into one? Watch this video till the end to find out. When it comes to cosmology, perhaps there is no bigger name after Einstein than Stephen Hawking. An icon of modern physics, his contributions changed what we know of the universe and helped us get closer to the biggest enigma of cosmology, black holes. However, being a great scientist is not just about always being right, but also recognizing the mistakes you made over the course and correcting them. Stephen Hawking played a crucial part in the discovery of the black holes, but even he now and then got something wrong about them. You cannot blame the guy.
You're an idiot.
Black holes are such an anomaly that they defy every single rule of physics, so you cannot hit the bullseye with every calculation regarding them. And there would be some wild swings here and there. Since the 1970s, Dr. Hawking had insisted that black holes are super concentrations of gravity created by burned-out stars. According to him, these space monsters swallow up matter and energy that never reappear except as an unrecognizable flash of heat. But in 2004, during the 17th International Conference on General Relativity and Gravitation in Dublin, Dr. Hawking admitted that he was wrong. A major question in theoretical physics that existed since Hawking discovered black holes radiating thermally in 1974 was, is information lost in black hole evaporation? According to Hawking in 2004, it was finally solved. He corrected himself by saying that his new discovery has made him realize that information about matter swallowed up in a black hole isn't really lost after all. Stephen Hawking found out that the quantum effects would cause a black hole to radiate at a steady rate. That means that, unlike as believed before, a black hole isn't a cosmic god that is eternal as the classic black hole theory had suggested. Instead, a black hole eventually disintegrates and disgorges the matter and energy in a distorted form. If you explain a black hole to a person who may have not ever heard of it before, he may imagine it as a big black sphere of eternal void in space devouring anything coming its way. Or they may imagine it as an actual black hole, like the ones you may have seen in the Looney Tunes show. However, not all black holes are black spheres in space, as light can still be emitted from the region outside the event horizon. In fact, some black holes tend to be the shiniest, brightest known objects in the universe. Astronomers call them quasars. If you do not know what a quasar is, here's a simple explanation. A quasar is essentially a supermassive black hole feeding on a huge amount of gas at the center of a distant galaxy. That makes quasars a different breed of black holes that are generally formed by the collision of two galaxies, gorging on the inflowing material in the gaseous form. As the gas spirals around it and falls in, the gas heats up in the process that leads it to emit radiation across the electromagnetic spectrum. This radiation is immensely bright, and the whole galaxy lights up like a stadium hosting the Super Bowl, only millions of times brighter, making the black hole look not black. Coincidentally, there is another reason a black hole may not seem black. It can be because of the way it may distort time. This is more of a perception trick, but due to the immense gravity of a black hole, it can make things heading towards it look stationary from far away. For example, a spaceship heading straight towards a black hole can appear standing still to a third party, never actually reaching the black hole. Similarly, a light source that has been sucked by a black hole could look eternally floating in the space between the observer and the black hole. This bright object would keep getting redder and redder, then fainter and fainter until it would eventually disappear. Astronomers call it red shifting. As we discussed before, black holes aren't actually a hole or a portal, as they draw in Looney Tunes in the space-time continuum. It is instead a region of space where time and space just get very weird and incomprehensible. We still do not know exactly what lies beyond the event horizon and unfortunately have no feasible way to figure out that mystery for now. Yet there are still some scientists who do believe that certain black holes can be portals to other places in the universe, aka wormholes. On paper, black holes sound like a vacuum cleaning service of the cosmos. Due to their nature of being a singularity, a ball of nothing but extremely crushing gravity, they are so powerful that it distorts space and time around them. But that doesn't mean they suck everything like a giant vacuum cleaner. Even though black holes are extreme in many ways, they don't have infinite mass. That means even though they have an immense amount of gravity, their force is still determined by the amount of mass that particular black hole has. Stellar black holes, for example, only have the mass of a very massive star. So just like an object can orbit around a massive star without being pulled towards its center, the same objects can happily orbit around a stellar black hole forever. But we would still advise to not get super close to a black hole though. The story would be very different from there on. When black holes were first discovered, people believed that they were a sort of a fixed point in space-time destined to drag all nearby matter and energy towards them to their eventual fate. However, as we noticed, they do not suck everything all the time, and similarly, they do not like to stay stationary either. Like galaxies, stars, planets, and everything else in the cosmos, black holes like to travel across the universe as well. This is why two black holes would collide or merge. Frankly, this is exactly how we found out about their mobility because the very first gravitational wave detected in 2015 was the result of a collision between two black holes that ended up merging. A lot of people believe that all stars end their life cycle as black holes, but astronomers have proved long ago that it isn't true. Stellar black holes are definitely formed when a massive star runs out of fuel and collapse in on themselves, leading to a cataclysmic implosion, but that fate isn't sealed for every star. For example, our Sun or any other star of similar size would likely end as a white dwarf. Even more massive stars have no certainty to end up as a black hole. If the star's core manages to resist the gravitational collapse, it becomes a neutron star instead. It is believed that a star has to be at least 20 times the mass of the Sun before it can be anywhere close to ending up as a stellar black hole. Also, we are still figuring out where the supermassive black holes come from. They could or could not be formed from stars. As a black hole's gravity is so immensely powerful that it distorts time, any object falling into it would look spaghettified from a safe distance. Spaghettification is the effect of amplification until the object is eventually ripped into a string of individual atoms. Researchers tend to believe that spaghettification always happens at the event horizon of a black hole. However, that is not the case. Though spaghettification is a real phenomenon related to black holes, exactly where it occurs can vary from black hole to black hole depending on its size. For example, in the case of supermassive black holes, it would happen way later after passing the event horizon. Though it is a fact that once the light has passed the event horizon, there is no hope for it to escape due to the near infinite strength of gravity in there, that fact doesn't make a black hole invisible. We can still observe black holes by observing how stars around them move. This was the method used to spot Sagittarius A for the first time. In fact, now we can photograph these suckers. Pun intended. Telescopes can also spot black holes by spotting the large accretion disk of stars, gas, and other materials spiraling towards the center as they did in the case of the M87 supermassive black hole. The material in the accretion disk is heated by friction as it swirls near light speeds and emits electromagnetic radiation. Though it is true that nobody could survive the immensely crushing gravity of a black hole, surprisingly, that won't be the reason for your death if you ever fell into a black hole. It is in fact the spaghettification that would disintegrate you before gravity can squeeze your insides out. We discussed what spaghettification is earlier in this video. So, as you can imagine, before you could get any close to the black hole to be compressed by its immense gravity, the process of being amplified would tear you apart into molecules. And it will happen long before you could feel the weight of the entire universe crushing you in your last moments. Since the conceptualization of the Large Hadron Collider, the world's biggest particle accelerator, there have been rumors and fear among the general public and certain parts of the science community that the particle accelerator would be powerful enough to create tiny black holes that would end up destroying us all. But the scientists of the LHC, credited for proving the existence of the Higgs boson particle, successfully demonstrated that it wasn't the case. The particle collisions that occur at the LHC are nothing different than collisions that happen in nature on our very Earth all the time. LHC only makes them happen in isolation so physicists can observe and study them. In fact, even if we could harness all the mass of every single object in our solar system, it won't be anywhere sufficient to create a stellar black hole. Some people were also worried about the LHC creating microscopic black holes, but even cosmologists aren't sure if they actually exist. So what do you think? Do tiny black holes exist in the universe? Did we miss any theory in this list? Tell us in the comments. Please give us a thumbs up if we kept you engaged and subscribe to our channel so you don't miss a thing.